Welcome to cryptography session. Today I am going to give an explanation of AES algorithm. The expansion of AES is Advanced Encryption Standard. It is one of the symmetric block cipher encryption algorithm. Then the basic design features of DES is also applied in AES. The basic design features of symmetric block cipher is plain text size, key size, number of rounds, subkey generation algorithm, and round function. So these five concepts is also applicable in AES. The only difference is the plain text size and key size will be varied. If we take 128 bit of plain text, then the key size may be varied. We can able to take either 128 bit of key, otherwise 192 bit of key, or 256 bit of key. So according to the size of key, the number of rounds is also varied in AES algorithm. And AES does not support a PSL structure because the encryption procedure is not same as a decryption procedure. So the procedure which is applied in encryption and decryption are entirely different, so that only AES does not follow a PSL structure notation. And it is also implemented in C and Java notations. There are four separate functions are available in a round function. So those functions are substitution, permutation, arithmetic operation, and XOR key. So that is named as byte substitution, shifting rows, mix columns, and add round key. If you go for a DES algorithm, in each round function, expansion, XOR, substitution, and permutation is available. So in DES, these four operations are performed in each round function. But in AES, first substitution is performed, then permutation, and then mixed columns and add round key. So these operations are the basic operations which are all done in AES algorithm. So the same concept is displayed in a diagrammatic way. So the 128 bit of plain text is converted into 128 bit of ciphertext, and the key ranges from minimum 128 to maximum 256 bits. And depending upon the key size, the number of rounds will be varied. If we take 128 bit of key, total number of rounds should be used as 10. For 192, we should use 12 rounds. For 256 bit key size, we should use 14 rounds. So this is the overall idea of the performance of AES. So 128 plain text is given to pre-round transformation. In pre-round transformation also, the subkey will be used, and then total number of rounds, then 128 bit ciphertext key will be retrieved. For generating subkeys, we are taking 128 to 256 bit of key. By the usage of expansion technique, the 128 bit key is retrieved from the given ciphertext. So this is the overview idea of implementing AES algorithm. And the initial round, that is pre-transformation round, only one operation is performed, that is add round key. And for all rounds, remaining rounds, substitution bytes, shift rows, mix columns, and add round key operations will be performed. But at last round, only substitution, shift row, add round key is used. There is no usage of mixed columns. This is the AES algorithm overview. So in a diagrammatic way, if you check that, this is the pre-round transformation in which round key is used. So add round key means we should use subkey. So this key is represented as a word. So totally 4 words are used in each round. So total key size is 128 bit key. So there are 4 words are used. So each word contains 32 bits. So this is the representation of this one. So if you combine 4 32-bit values, continuously, then we may able to get one round key. So that will be used pre-round transformation, and then in each round also keys will be generated. So this is the expansion operation. So for each round, substitution, shifting, mix row, add round key is the procedure. But if you go for the 10th round, mix column operation is missing. So this is 10 rounds with the 128-bit key size. And in reverse procedure, the encryption is not same in decryption. Instead of shifting, here in decryption, inverse shifting is available. Instead of substitution, inverse substitution is there. Instead of mix column, inverse mix column operation is performed. So it is not same as the encryption procedure, so that only AES does not follow FASL cipher structure notation. And if we take 128-bit value, that will be stored in 16 values. 16 value means 4 cross 4 matrix, the values will be stored. So totally 128 bits are available. Total value should be 16 values. So each value should be represented as an 8-bit representation. So this is 8-bit, this is 8-bit, this is 8-bit, this is 8-bit. So if you combine continuous 8-bit, we are taking 32-bit value. So each box contains an 8-bit value in it. Either the value will be stored in column order, otherwise it's stored in row order. Here I am explaining the concept in column order. So if you take key, 128 bits are available, but we should take at least maximum 4 words in each round operation. So each word contains a 32-bit notations in it. So this is the relationship between byte, word, block and state. So if you take a continuous 8-bit value, that is called as byte. So this byte value either represented in row order or column order. And if we combine 4 bytes, so this is byte. So here B0, B1, B2 are called as bytes. So each byte contains 8-bit value. So if you take 8 word means word is a 32-bit value. So either we can combine continuous 4 values at row or column. So if you take block, so this is one word, this is one word, this is one word, this is one word. So this is a state value. So state means S of 0, 0. So you can able to store these values in column order. So these are column values. So if you represent it as a 4 cross 4 matrix, it is called as state. That is only the difference between the block and state. A 4 cross 4 matrix representation of data unit is called as state. And the state value will be combined as a formation of word by adding continuous 4 values in row order or column order. So here I am taking the plain text as AES uses a matrix. So totally 14 letters are used, but we should create a state array with 16 values. So the last 2 letters will be taken as Z. So its corresponding binary value, decimal value is represented. So this is state array in which the first 4 letters are stored in first column. Next 4 letter values are stored in second column. So I am storing the values in column order. So this is the plain text state value. So this first state is your plain text value. So the plain text value is stored in decimal format of column order. Then the round function operation is performed with 4 different operations. One is substitution, shifting, mix columns, add round key. For each operation also totally 16 values will be retrieved. So the input of round function and output of round function is only the state value. Byte substitution means here we are taking only one S box. one S box contains 16 cross 16 values. That means maximum 256 values are available. So this is a single S box. So compared to the AES algorithm, here AES algorithm contains only one S box, and the S box rows are named as hexadecimal value. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then after that A, B, C, D, E value. So totally 16 columns. Here also 16 rows and then 16 columns. So this is the general representation. Suppose the first value is 8A means I should refer 8th row and 8th column. So I should refer 8th row and 8th column. So this is the value. So which value is available in this S box? That will be copied to the output of this substitution box. In this way, totally 16 times this S box is referred and 16 values will be retrieved from this S box. So this S box contains independent 256 values in it. There is no values are same. So this is the substitution mechanism. So this is the example of S box value. So totally 16 rows, 16 columns. So up to F, the answer is available. For example, the first value EA means I should refer E row and A column. So in A column, the number is 87. So that will be copied to the output of substitution box. Then I am taking 83 means 8th row, 3rd column. So the answer is EC. That will be retrieved here. So in this way, S box output is stored in also state array. Then the bottom portion is for decryption purpose. At a decryption side, we should refer the inverse S box value. For example, if this second matrix values are retrieved at a decryption side, so if 87 is available, I want to refer 8th row and 7th column at inverse S box. So 8th row, 7th column, the answer is CEA. So in this way, the S box values are retrieved. So this is the first operation. Second operation, shift row means, so that state array value, we are not changing the first row value. So the first row values are unchanged. In the second row, we only change the values at one left set plus shift. If it is a third row values are shifting with 2 bits. At fourth row, 3 bits are shifted. For example, so this is the input which will be taken from the substitution box. So if I give this state array in a shift row operation, so this is the first row, row 1. So row 1 values are no change, so I am writing that values as it is. So this is the second row, so I only change one left surplus shift. So left surplus shift means 6E, 4C, 90, then EC will be stored at last column. If it's a third row, I should shift 2 bits. So 46 E7 4A C3. If it is a fourth row, 3 bit left surplus shift. So A6 8C D8 95. So in this way, shift row operations are done. Then the next remaining operations will be discussed in next session. Thank you.